In this video, we're going to take a look at the nomenclature rules for alcohols. So generally, these are very similar to nomenclature rules that we've seen for other types of organic molecules. And so our goal, though, in this case is to find our parent chain, which is the longest chain that contains OH. In fact, the OH takes greater priority or takes priority over the carbon-carbon double bonds or the carbon-carbon triple bonds. So if you see an OH, you want to make sure you prioritize that in your parent chain, and you want to try to get the OH to have the smallest substituent number possible. And then where possible, if you can, try to include the double bond and the triple bond in your parent chain as well, just because it makes it a bit easier to name. If you have a weird substituent with a double bond or triple bond in it, we haven't really learned naming for that. So OH for sure has to be in the parent chain, then where possible, get the double bond and triple bond in there as well. So what you're going to do is you're going to name the parent chain based on the number of carbons it contains. And instead of having the ane or ene or ine ending, you're going to have the all ending to represent an alcohol. You do have to represent where the OH is located on which carbon. And so to do that, almost like you did with the enes and the ines, you would put a number in between the N and the OL to show what location that hydroxyl group is on. If you have a polyalcohol that contains many hydroxyl groups, then what you're going to do is you're going to name the alkane with ANE at the end, and then you're going to put the positions of both, and then put the prefix that indicates how many there are. Like if there's 2, it's di; if there's 3, it's tri; and then all afterwards. And then you want to number your carbons and list your other substituents alphabetically like you normally would. So really the main difference is what you're prioritizing when you're finding your parent chain. It's the OH group, and then the ending that you're using, which is the OL. So there's a couple other minor things, but that's the main difference there. So it's really nothing that much more difficult than what you've already learned. As usual, if the main chain has an alcohol in it, add cyclo to it. So for example, here, there's 6 carbons. So this would be cyclohexanol or hexan 1-ol. Doesn't really matter what you say because it's just carbon number 1. If you have a parent chain that has benzene and OH, we call it benzenol or phenol. Either one is used. You can use them interchangeably. So as I mentioned before, hydroxyl groups have higher priority than double bonds, triple bonds, and these other groups called, and also alkoxy groups and amines and all other alkyl groups and halogens as well. There's a priority list that I will show you later on, but just remember that hydroxyl has some pretty high priority. If it ever happens that hydroxyl is lower in priority and there's some other functional group that's higher, you would call your hydroxyl group a hydroxy substituent. We won't see a lot of that right now. We're going to focus mostly on alcohols being the priority. So let's go ahead and try to name some of these alcohols over here. We'll start with the simplest one. If you want to pause the video and try it yourself first and see if you understood the rules, go ahead and do that, and then unpause and check if you're right. So this is the OH over here. I have to count the number of C's in my molecule. So this is a C here, 1, 2, 3, 4, 5. So that's a pentan 1-ol, or simply pentanol, because when you have position 1, you don't have to put position 1 there for alcohols. So pentanol. So now here we have a benzene ring, and we need to try to find carbon number 1. So the hydroxyl group is our priority. So that's carbon number 1, carbon number 2, and then you can number all around if you want, but it's not necessary since there's no other substituents. And so you can call this 2-methyl phenol or benzenol. That's one word. Let's erase that to make that one word. Benzenol or phenol. All right, so now we're going to get a little bit different here. Here we have an OH group. Notice it's not attached in carbon number 1 anymore. We have to choose a direction to number. You can number from here to here or the other way around. And you need to choose the best system. So if you numbered this way, you would get 1, 2, 3, 4, 5. But if you numbered the red direction, you would get 1, 2, 3, 4, 5. So you want to choose the one where your hydroxyl has a lower number, and that happens to be the blue direction. So we have a pentan 2-all. That would be the alcohol pentan 2-all because the OH is on the second carbon. And then just before we go on the next row of alcohols to name, I want to classify these as primary, secondary, tertiary. So this is attached directly to one other carbon, so primary. This one here is attached to two other carbons, so secondary. And this one here is attached to two other carbons as well, so also secondary. Okay, so now we're going to go and try to name these ones, and you can try them on your own since you have some experience now. So here's the OH group. I'm going to try to find the longest chain that contains the OH group, and it looks like it's going to be this one here. We want to start counting from an N that gives us a low number for our OH, low number for everything, but especially that OH. And it looks like this is the best N to count from. 1, 2, 3, 4, 5, 6, 7. So we have 3, 1, 2, ethyl, heptan 2-all, heptan 2-all. And then just like before, this is also a secondary alcohol. Okay, so longest chain that contains this OH, it looks like it's going to be this way. That's 1, 2, 3, 4, 5, 6, 7, 8, as opposed to 1, 2, 3, 4, 5, 6. So we can start counting from here to get the lowest number possible. 1, 2, 3, 4, 5, 6, 7, 8. On carbon number 3, we have a 1, 2, 3 propyl. So 3 propyl, and then it's 8, so octan 2-all. And this would be a, let's see, 1 and 2, secondary alcohol. Okay, let's go on to this one over here. So we have an OH group here. We got to start numbering to get the lowest possible number for the alcohol, if possible. And so in this situation, it would be the 1 here, then 2, 3, 4, 5, 6. I know it might be better to start at a methyl and then get 1, 2, 3, but then your OH would be a little bit too high. You really want that OH to be as low as possible, and so the best way to do it is to have that as carbon number 1. And I know it's a bit of a sacrifice for this methyl here, but it's a sacrifice we have to do because OH does have a really high priority. And luckily, this methyl here is already pretty low in priority. So what do we have? We have 2,6-dimethyl benzenol or phenol. Okay. And let's label that as a secondary, primary, tertiary. So this carbon is attached to 1, 2, so secondary alcohol. Now let's go and do the last row over here. So we want to get that carbon into the main chain. And it looks like this is going to be our main chain here. We got to number this to get the smallest number possible for the alcohol. It takes priority over the double bond. So best way is 1, 2, 3, 4. Because if we went the red direction I'm about to do here, the OH would be too high. 1, 2, 3, 4. 2 is better to have than 3. So we're going to go the blue direction. So we have no substituents, so we do have double bonds here. And so our general rule when you're doing that is you have to go back and review the naming rules for double and triple bonds. It's still the same naming rules, but you do need to also include the position of your alcohol along with your double bond. So normally this is a butanol type of molecule, but this time we have a bute. Position of our double bond is 3, bute 3. Then you can say ene, but instead of ending with an E at the end, you're going to put the all, but you have to put the position of the all. So that's ene 2 all. So bute 3 ene 2 all. So you've tried that one, or we've tried this one together. Now try the next one on your own. Longest chain that contains the OH, and if you can, include the double bond as well. And it looks like we found that here. In this case, the best way to count would be this direction here: 1, 2, 3, 4, 5, 6, 7, 8, 9, because you get nice low numbers for both. If you went the other direction, you get a pretty high number for the OH and also for the double bond. So we have 9. So we have non, 1, in, and then 3, all. So now we have a polyalcohol for the last one. Oh, we forgot to label these as primary, secondary, or tertiary. This one is connected to, the carbon is connected directly to 2, so secondary. This one, same idea, so secondary. Let's go over here now. So longest chain that contains the alcohol, which is basically this here. And it's pretty apparent we should probably start numbering from the end over here, because you get much lower numbers with the OHs since they're all at that end. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so we have decane, because it's an alkane base, as there's no double bond, triple bonds. Then we have to put the locations of the OH, so 1, 2, and 10. And then triol, because there's 3 alcohols there. And so what we just did here was name a bunch of alcohols using the alcohol naming rules that were listed over here. So always start off by reading over the rules, and then after you read the rules, you can apply those rules to the different drawings. Retry these ones again before you go to the worksheets and other practice problems until you can do these without any great difficulty. If we had to classify this one, by the way, as primary, secondary, tertiary, it's a bit harder to do if you have a variety. So for example, this point here, this would be a primary one, but this one over here would be a secondary one, and this one here would be a primary one. So they're different sites, and they might react differently at those different sites in certain reaction conditions. In the next video, we're going to do some examples where we need to either name or draw alcohols from a name.